Hello, hi everyone. Welcome to the student the brand. Welcome to the class. So now we will discuss about motion in a straight line. Motion in a straight line. So motion in a straight line means okay. So if you want to describe the object, if it is required only one axis. Okay, so only one axis required for describing the object, then the body is moving in one dimensional motion, that is nothing but motion in a straight line. Motion in a straight line. Okay. So motion in a straight line. Now, first we will discuss right from starting onwards. First one is rest. Rest. Second one is motion. First we will discuss about these two terms. First one is rest. So you placed a book on the table. You placed your college bag on the table. So you throw an object. Okay. So like a stone. Or you place an object on the table. So you place just okay. It's exam pad on the table. So you went for playing. Okay. So not during exam time. So remaining time. Okay. So you went for playing. After certain time, after playing games, so you came to your house and observe these things. Will they move by their own? Right? Normally. So other than anyone is placing things in some other position or some other place. So don't think about all the other cases, all other possible cases. So think about only you place the object. So you went for playing. After that, again you come back. So you came back to house and observe all those things. So will they move by their own? So with respect to time and with respect to surroundings, not at all, right? So those objects are not moving. Okay. So those objects doesn't displace from their position. Yes, sir. With respect to time and with respect to surroundings. Okay, so if the body is not moving, okay, if the body is not displacing according to time with respect to surroundings, as time goes, as time passes, if the body is not moving with respect to surrounding, then the body is said to be in rest. Then the body is said to be in rest. Okay, and coming to the okay, so coming to the motion. So this is the rest coming to the motion. Motion means as the body is moving, as time is changing, okay, as time is passing, as time is changing, okay. So the body is not moving, not the body is moving here. The body is moving with respect to surroundings, okay, with respect to time and with respect to surrounding. If the body moves, okay, then it is called the body is in motion. Understood? Rest and motion are relative terms. Rest and motion are relative terms. How can you say, sir, rest and motion are relative terms? Rest and motion are relative terms. I'm standing here. Okay. I'm standing here. Okay. I'm standing here. So the fan is rotating. With respect to me, the fan is in motion. So you're standing in the railway station. You're standing in the railway station. With respect to the train is moving. Okay. So one more person is there in the train. So best example, two persons are there in the train and one person is there in the platform. So two persons are A and B are moving in the train and person C is moving. So person C is standing in the in the platform and observing those two persons. So with respect to C, person A and B are in motion. Yes, sir. Person A and B are in motion with respect to C. But with respect to A, the person B is in rest position because they are sitting each other. So they are sitting, okay, nearby only, right? Understood or not? Understood or not? I hope it is very clear. So they are sitting besides of them. So besides of each other. So person A is sitting besides of person B. Person B is sitting besides of person A. Okay. So like that. So with respect to A, B is at rest. With respect to B, A is at rest. But with respect to A and B, C is at rest. Sorry, C is in now A subcourse rest. But with respect to C, C is in rest position, but A and B are moving. A and B are moving. Yes or no? A or B are moving. Understood or not? I hope it is very clear. I hope it is very clear. Understood? Yes. So now, so what I'm trying to tell. Now, so we'll discuss about distance. Distance. Third point is distance. Distance. The total length covered by an object is called the total length covered by an object is called distance. So I'm taking here this is a point A and this is a point B. Okay, point A and point B. This is a point A and this one is point B, right? So point A and point B. Understood or not? So I can take this path. I can take this path and I can take this path. I can take this path like this. Or any path I can take, right? I can take any path like this. So I want to move from point A to point B. So I want to move from point A to point B. I can take any path. The total length of the path covered by an object. The total length of the path covered by an object is called distance. The total length covered by an object is called distance. Is it clear? And from A to B, I can reach like this also. Directly it is, so we can take like this also, right? That is called the shortest path from initial point to final point. The shortest path from initial point to final point is called displacement. So fourth one is displacement. Displacement. The shortest path from initial point to final point is our starting point, ending point, or from point A to point B. Like that we can take. So here, distance is a scalar quantity. So distance, SI unit of distance is meter and dimension formula is either we can write like this m power 0, L power 1, T power also 0. Only length is there. Understood or not? I hope it is very clear. M power 0, L power 1, T power also 0. Right? So M power 0, L power 1, T power 0. This is the distance. Coming to displacement. So displacement is a vector quantity, and a displacement SI unit is meter, and displacement dimension formula. So we can take capital L, or simply we can take M power 0, L power 1, T power 0. Like this also we can take. So displacement is a vector quantity. So here again, here one more point. So first one is scalar. Second one is vector. So what is scalar and vector? Scalar is nothing but the physical quantity which has only magnitude. The physical quantity which has only magnitude, that is called scalar physical quantity. Example, mass, length. So like speed, density. So coming to the vector physical quantity. The physical quantity which has both magnitude and direction. Here displacement. Displacement has both magnitude and direction. That's why it is a vector quantity. So I did one video. So I made a video regarding scalars and vectors. Once check it. Once observe. Okay. So scalars and vectors. So in that I explained very clearly about so scalars and vectors related to vectors, types of vector, addition of vectors, product of vectors. Okay. So I explained all those things. Right? Yes. Now speed. Speed is nothing but distance by time taken. Speed is nothing but distance by time taken. Coming to the fifth one, speed. And coming to sixth one is velocity. And next one is acceleration. So speed is nothing but distance by time taken. So I'll explain about speed and velocity differences. Speed and velocity. So first one is speed is a scalar quantity. Speed is a scalar quantity. Second one, speed is a scalar quantity. SI unit of speed is meter per second. And damage formula is M power 0, L power 1, T power minus 1. Okay. I hope it is very clear. Understood or not? Right. And anyway, definition, distance by time taken only. So you have to write first, then you have to write remaining, but I'm writing at the end. Coming to velocity. First, velocity is a vector quantity. So meter per second. So dimension formula is M power 0, L power 1, T power minus 1. So M power 0 we have to write. M power 0. Okay, and coming to the fourth one, displacement by time taken. Displacement by time. Okay. Speed is a scalar quantity. SI unit of speed is meter per second. So damage formula. So speed equal to distance by time taken. Coming to velocity, velocity is a vector quantity. SI unit of velocity is meter per second. And the damage formula. So formula. So coming to acceleration, acceleration is nothing but A equal to change in velocity by, so change in velocity by time taken. Simply we can say final velocity minus initial velocity by time taken. Final velocity minus initial velocity by time taken. I hope it is very clear. Understood or not? Final velocity minus initial velocity by time taken. That is called acceleration. Here we have to discuss about 3 points. One is, I'll discuss here. Okay, so now first point is average speed. Average speed. Second point is instantaneous speed. Instantaneous speed. And third one is uniform speed. Uniform speed or non-uniform speed also we can take. Uniform speed and non-uniform speed. So average speed, total distance by total time taken. Total distance by total time taken is called average speed. Instantaneous speed, speed at particular instant. And coming to the uniform speed, so the body covers equal distance in equal interval of time. The body covers equal distance in equal interval of time. That is called uniform speed. So same, we'll get average velocity, instantaneous velocity, uniform velocity. Average velocity, total displacement by total time taken. Total displacement by total time taken is called average velocity. Instantaneous velocity, velocity at particular instant. Velocity at the particular instant is called instantaneous velocity. And coming to uniform velocity, body covers equal displacement in equal interval of time. Equal displacement in equal interval of time, that is called uniform velocity. So coming to average acceleration, instantaneous acceleration, uniform acceleration. Average acceleration. So the total change in velocity by total time taken by, and instantaneous acceleration, acceleration at the particular instant. And coming to uniform acceleration. So equal change in velocity in equal interval of time. Equal change in velocity in equal interval of time. So that is about average speed, instantaneous speed, uniform speed. Average velocity, instantaneous velocity, uniform velocity. Average acceleration, instantaneous acceleration, uniform acceleration. I hope it is very clear. Understood or not? Next we'll discuss about equations of motion by calculus method. Next, equations of motion by calculus method we'll discuss. So let's start. Equations of motion by calculus method. Okay. So now So body is moving with the constant acceleration A. So A equal to dv by dt. dv by dt. So dv equal to integral. Sorry. A into dt first you have to write. Later you can take integration on both sides. So A into dt. Then you take integral. So integration on both sides. Then integral u to v dv equal to A into integral 0 to t dt. Okay. So then we can write. So v. So u to v and A into t 0 to t. Then v minus u equal to A into t. Then v equal to u plus at. That is equation 1. So this is the equation 1. Understood or not? Equation 1. And coming to the next one. So same equation. V equal to u plus at. Then I'm writing dx by dt equal to. So u plus at. Then dx equal to u plus at into t dt. Right? So now you can take integration on both sides. So 0 to x dx equal to 0 to t u plus at into dt. Then you'll get, so here x 0 to x equal to u take outside 0 to t plus a into t square by 2 into 0 to t. So x equal to ut plus half at square. This is equation 2. So this is equation 2. Understood? Now, last equation. So here you can take v equal to u plus at square on both sides. Square on both sides. So if you square on both sides, you will get v square u plus at whole square. Then v square u square plus 2u at plus a square t square. Okay, so then v square u square plus 2a you can take common ut plus half at square. Ut plus half at square is x. So then v square equal to u square plus 2ax. So this is the equation 3. Okay, so that is equation of motion. That is the third equation of motion. Understood or not? So I hope it is very clear. Understood? So check once. A equal to dv by dt, dv equal to a into t. A into t, so integral u to v dv a into 0 to t. So we'll get equation 1. After that you are taking second equation. So you'll get second equation by doing square on both sides. Then you'll get third equation of motion. Okay, so this is about equation of motion by calculus method. Now we will discuss about equation of motion by graphical method. Equation of motion by graphical method. Okay, so I'll discuss that one. Equation of motion by graphical method. Okay, equation of motion by graphical method. Equations of motion by graphical method. Equations of motion by graphical method. Okay, so we have to use by graphical method. So here I am taking this object mass m at position A and reach it to the position B. Same mass, initial velocity. So initial velocity U, final velocity V, and acceleration A. So time, distance and time. Distance and time. I hope it is very clear. Understood or not? Distance and time. Right? So the same will be representing on graph. Velocity on y-axis. So time on x-axis. So this object A at initial velocity U reach it to position B with the final velocity B. Okay. So then you can take here and here. So this the 0 CD. Okay. So this the initial velocity U and this the final velocity V. This the change in velocity. Right? So time t, time t. Understood or not? I hope it is very clear. So I hope it is very clear. Now you can see first equation of motion. So we have to write first equation of motion. So observe carefully here. Observe carefully the diagram. Okay. Understood? So now you can see here from velocity time graph. Velocity time graph. Okay, slope. Okay, slope equal to change in velocity by time. Change in velocity by time. So meanwhile, you have to write the terms. What are the terms we are using here? So here you can see those are OCAD. OCAD equal to T and CD and OA equal to U and BD equal to V minus U, right? So these are the terms. Then substitute A equal to change in velocity is nothing but V minus U by T. So from this V minus U equal to A into T. So now we can write T equal to V minus U by A. That is the equation 1. So from that, so just keep it like that. So I'm not writing. Okay, so final equation we didn't get. Now V equal to U plus AT. This is the final equation. So equation 1. So we have to substitute T value. That's why I'm mentioning. Now we can take position and time relation from same graph. So that is area of the rectangle plus area of the triangle. That is a trapezium. So yes, S equal to area of rectangle. Rectangle. What is a rectangle? OADC. OADC plus area of triangle. Area of triangle. What is a triangle? ADB or ABD. Anything you can take ADB. Now S equal to OC into OA. OC into OA plus half into AD into BD. BD is nothing but right? So here V minus U equal to A into T. So we can substitute V minus U equal to A into T can substitute, right, in the equation. Okay. Right now you can see S equal to OC is T into OA is U plus half into AD is nothing but T and AT. So S equal to UT plus half AT square. So this is equation 2. Then so you can see from the same graph position and velocity relation. So area of the trapezium, that is nothing but OA plus so BC plus so OC in by 2. That is nothing but U plus V into T by 2. So T value equal to, you have to substitute the T value. So here U plus V by 2 into V minus U by A. So we know U A plus B into A minus B. Okay. So now S equal to V square minus U square equal to 2A. Then V square minus U square equal to 2AA. Understood? So I hope this is the third equation of motion. Right? So I hope it is very clear. Understood or not? So this is about equation of motion by graphical method, at the same time by using calculus. By using calculus. Understood or not? Once again, so observe carefully here. So object is at position A. So it travels certain distance after certain time it reaches to the position B, final velocity B, acceleration A. So same situation we are representing on the graph. Okay, so position A, initial velocity U, reach to final position, final velocity V. So this time, okay. So time is T. Then we are taking, so OA is initial velocity and CD also initial velocity. BC or CB equal to final velocity. So the difference is change in velocity, right? So BD is change in velocity, V minus U. So then from that Vt graph, slope equal to change in velocity by time, A equal to V minus U by T, V minus U equal to A into T, T equal to V minus U by A. So we are substituting this value here. That's why I'm mentioning like this. So V equal to U plus AT, first equation. Then position and time relation from the same graph, S equal to area of the rectangle OADC plus area of the triangle ADB. Then you will get so S equal to UT plus half AT square. And coming to third equation, position and velocity. So same graph, position and velocity relation. S equal to OA plus it is in the trapezium. So area of the trapezium OABC. OABC, that is OA plus BC plus OC. Or BC plus CB, same. Okay. That's why I'm writing here initial velocity, final velocity by 2 into T. So T is nothing but V minus U by A, that you are substituting. Then you'll get S equal to V square minus U square by 2A, V square minus U square equal to 2AS. So that's enough. This is about a third equation of motion. So I hope it is clear. All right. So if you like the content, if you like the channel, so do like, share, and subscribe to Student the Brand. If you like the content, if you like the explanation, so you can inform to your friends, ask your friends to join to the class, ask your friends to so join to the class. So if they like them, do like, share, and subscribe to Student the Brand and share to everyone. So they will also get to know. So there's a physics class is going on here. So thank you so much for joining and attending and listening my class. This is our Savasa signing off. Thank you.